Today we're going to learn how to add and subtract rational expressions and how to simplify complex fractions. When you add and subtract fractions, your denominators need to be the same. To find our least common denominator, we find the least common multiple of the existing denominators. So let's practice finding the least common multiple of some expressions or terms. The least common multiple of 4, 12, and 18 is 36. We can check by dividing each of the terms by 36. It should divide evenly. We should not be left with any fractions. When we divide, we have integer answers and not rational answers, so we have found the term that each of the other terms is a factor of. The least common multiple of 6x squared, 2x cubed, and 4x. The least common multiple of 6, 2, and 4 is 12. The least common multiple of x, x squared, and x cubed is x cubed. You cannot have less than the biggest amount. So if there's an x cubed there, then at least x cubed will be a part of your least common multiple. After we divide, we have no rational terms left, indicating we have found our least common multiple. For the least common multiple of x squared minus 6x plus 8, x squared minus 4, and x plus 2, we'll need to factor the quadratic expressions. Our least common multiple needs to be a multiple of each of these factors, which is why we factor. The first factor we need to include would be x minus 2. We don't need to write it twice though, because it is found once in two different expressions. So it is common to each of those. We only need to write it once. Then you have x plus 2 is common to the second and the third expressions. So x plus 2 can be written once. And finally, the factor x minus 4 must also be taken into account. Let's check by dividing our LCM by each of these expressions individually. Therefore, we have found our least common multiple. Now factor these expressions to find the least common multiple. So our least common multiple must include x minus 2 quantity squared, because one term has it squared, which means our LCM needs to have it squared in order to divide and get a non-rational expression. We also have x plus 2. That only needs to be written once. The x minus 2 quantity squared will cover this one, so we don't need to write a third one. Our third term is 4x, so we need something that 4x goes into. Well, I could say 4x, but oh wait, we have a 6 as a GCF of the first expression. So we can't just put 4x, we need a number that 6 and 4 both go into. So 12x. The x will take into account the x in the 4x, and 12 is the least common multiple of 6, 4, and 4. Go ahead and check. And so we have found our least common multiple. Now that we're familiar with how to find the least common multiple, let's combine some rational expressions. Wow, part A already has common denominators, so we just need to add the numerators. And state the excluded values. Excluded values would be whatever makes any of your denominators equal to 0. Our denominators were 4x and 4x. The only way for 4x to equal 0 is if x is equal to 0. You can check whether something is the least common multiple of your denominators, but unfortunately, you can't check if this is the sum of those two fractions. We can check our solutions for equations, but the only way to really check a simplification of an expression is to just double check, as in do the problem again and make sure you got the same answer. For part B, let's factor the denominators so that we can find the least common multiple. Our least common multiple is at least as big as our biggest denominator. So I always start there and then I adjust if I need to. I adjust by asking myself, do the other denominators go into this existing LCM? Well, 9x squared doesn't go into 3x. Would it go into 9x? Not quite. It would need to be 9x squared. Does 3x still go into 9x squared? Yes. So we have found our least common multiple. And you can check by taking the least common multiple and dividing each of your denominators to make sure you do not get a rational term or expression. Because our results are not rational and they do not have a common factor with each other, we have found our least common multiple. It's time to take each of these fractions and multiply them by a special form of the number 1 to get common denominators. When I divided the LCM by 9x squared, I got x plus 1. So our first fraction is missing x plus 1 in its denominator. I'll multiply the denominator by x plus 1, but in order to do that, I must multiply the numerator by x plus 1 because this is an expression. We cannot change an expression, we can simply rewrite it. We are not changing this expression because we are simply multiplying by a special form of the number 1. Our second denominator is missing 3x, so I'll multiply by a special form of the number 1 to get 3x in the denominator of the second fraction. Rewrite your fractions. Now at this point, you may be tempted to start reducing, but remember, we multiplied so that we could combine these. We don't want to reduce each individual expression, we only want to reduce the final expression. Now that we have the same denominator, we can combine our numerators. I'm also going to distribute 7 into x plus 1. Now that I've rewritten it in standard form, because the numerator is not factorable, there's nothing else we can reduce here. Now it's time to simply state our excluded values. This first denominator would be equal to 0 if x is equal to 0. This second denominator would be equal to 0 if x were equal to 0, or if x were equal to -1. And there's our combined ratio with its excluded values. Let's factor these denominators to find the least common multiple. Our least common multiple would be at least as big as our biggest denominator, and then the only thing missing is 2. Because we are subtracting these fractions, this minus is actually a negative that should be distributed into the numerator of the fraction after it. So I'm going to rewrite this minus as a plus and put the negative up here so I don't forget about it. The first denominator is missing the factor x minus 3, so I'll multiply by a special form of the number 1, x minus 3 over x minus 3. Keep in mind, this is a quantity that you're multiplying, so you will need to distribute. And our existing numerator is also a quantity, so put parentheses to make sure you remember to double distribute in this case. Our second denominator is missing the 2, so multiply by a special form of the number 1, 2 over 2. This -1 multiplied by this 2 would be a -2 times this quantity. Now that our denominators are the same, we can combine the numerators. I will also distribute the -2 into -2x minus 1. Combine like terms in the numerator. Always check to see if you can factor and reduce further. Remember, you cannot reduce unless everything is factored. So our answer is x plus 4 over 2 times x minus 3, and our excluded values would be anything that makes your LCM equal 0, so 3 and 1. For number 2, we'll simplify the following complex fractions. There are several ways to simplify complex fractions, but the way I have found myself most commonly doing it in the future is to combine the fractions in the numerator and the fractions in the denominator so that you can divide one fraction by another. To do that, we have 2 fractions in our denominator and we need to find their LCM. The LCM is not just x plus 4 because x plus 4 is a group. It's not just x, it's x plus 4. X does not go into x plus 4, so we need that x in front as well. Multiply each of these fractions by what they're missing in their least common multiple. Now you have one fraction divided by one fraction, so you can change it to multiply by the reciprocal of the bottom fraction. Reduce and simplify. Remember, for your excluded values, you need anything that made any denominator equal to 0. So 0 and -4. Try part B on your own and then press play when you're ready to check. Remember that the denominator of x plus 2 could always be written as x plus 2 over 1. I simply took a 2 out of the numerator so I could see if I can factor x squared plus 4x plus 10, but none of the factors of 10 add up to be 4, so we cannot reduce any further. You can write your answers factored or unfactored, but the thing is you have to check to see if they're factorable to see if you can reduce. Remember, excluded values would be whatever makes any denominator equal to 0. That would just be -2, which means you could also multiply out the denominator, but who wants to do that? And that is simplifying complex fractions.